Okay, just picking up where we left off. Triangles. I'm just going to go through this really quick because I'm pretty sure you already know this. But a triangle is a polygon with 3 sides and 3 angles. And the sum of the measures of the interior angles of a triangle is 180 degrees. We can classify triangles by their angles or by their sides. If we classify them by their angles, we would say that any triangle that has all angles less than 90 would be called an acute triangle. A triangle that has one angle that is bigger than 90 is called an obtuse triangle. And then a triangle that has a right angle we call a right triangle. If we classify a triangle by its sides, if all 3 sides are equal, we call it an equilateral triangle. And these little hash marks just tell you that these 3 sides have the same measure. They all have 1 hash mark, so they all are the same measure. The one in the middle is an isosceles triangle. That's a triangle that has 2 equal sides, and these hash marks show you that this left side is the same as the right side as far as length goes, because they each have 2 hash marks. A triangle that doesn't have any sides that are equal is called a scalene triangle, and you can see that one side has 1 hash mark, another side has 2 hash marks, and another side has 3 hash marks, and that means that none of them are the same, since they all have a different number of hash marks. So that's how you can classify triangles. So here we've got a triangle. We want to find x and y. We can see that this is an isosceles triangle, meaning that this side is the same as this side as far as length. And in an isosceles triangle, we say that the base angles are going to be equal because the sides across from them are the same, the lengths of those sides. So we know that those 2 base angles have to be the same. That's always going to be true in an isosceles triangle, a triangle that has 2 equal sides. So we know that 50 and x are the same. So x is 50. Now we know that 50 plus y plus x add up to 180 because we know the interior angles of a triangle all add up to 180. And so we can write that equation. 50 plus x, which is 50, plus y is a total of 180. So that's 100 plus y is 180. So y is going to be 80 degrees. Okay, so moving on to lesson 2, we're going to talk about exponents, and this again is something you already know. So here we have what is called a power, and it has a base, bigger number, and then it has a littler number raised up next to it, and that is called an exponent, or it can also be called a power. Exponents are used to express repeated multiplication. So just like multiplication means repeated addition, in other words, 2 times 5 means 2 plus 2 plus 2 plus 2 plus 2, which is 10. Exponents mean repeated multiplication. So when you have something like 5 raised to the 4th power, it means multiply 5 by itself 4 times. So 5 times 5 times 5 times 5. That's what exponents mean. That's what they do. Repeated multiplication. When we do arithmetic operations involving exponents, we discover the following properties. Number 1, we find out the product property, and this is sometimes called the product rule for exponents, but it's not really a rule. It's just something that this is how exponents act. All right. What you find out is that if you multiply like bases, so if you multiply 2 powers, if you multiply b to the m times b to the n, you can just add the exponents. You will get b to the m plus n. So if you have something like 2 to the 4th times 2 to the 2nd, that equals 2 to the 6th. And the reason I say it's not a rule, it's a property, is because that's just what happens, right? 2 to the 4th means 2 times 2 times 2 times 2, and 2 squared means 2 times 2. So you've got 6 of them. That's just what happens. When you multiply like bases, you can add the exponents. It just works out that way because of what exponents mean. So it's not a rule, it's not a definition, it's a property. It's a characteristic of exponents. It's just how they work. All right. So the power property for exponents. When we raise a power to another power, we multiply the exponents. Again, it's a property. It just works that way because b to the m raised to the n power actually does give you b to the m times n. When you raise a power to another power, you multiply the exponents. Because if you have something like 2 to the 4th power, and then you raise it to the 2nd power, that is going to be 2 to the 8th, because 2 to the 4th squared means 2 to the 4th times 2 to the 4th. That's what that means. And that's just 2 times 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 2. So there's 8 of them. And that's just the way exponents work. When you raise a power to another power, you multiply the exponents. And for the power property, we can call it the power rule or the power property, but I prefer the power property just because it is a property. It's a characteristic of exponents. It's the way they behave. It's not something that we decide about them. It's just the way they act. All right. So in the power property, it doesn't have to be just one thing raised to a power. It can be a whole string of things multiplied together. Now this all has to be multiplication raised to a power. That means you just multiply every single exponent by that power. One big trip up that you can get with this property is if you have something like 2x squared and it's raised to the 3rd power. It's tempting, for some reason, I guess just because you're multiplying, you might be tempted to multiply the 2 times the 3 and get 6x to the x squared to the 3rd would be x to the 6th. But this part is not right. 2 to the 3rd power is 2 to the 3rd power. The exponent on 2 is 1. So this is not 2 times 3. It's 2 to the 1 times 3. So 2 to the 1 times 3 is 2 to the 3rd, which is 8. So be very careful that you don't start multiplying exponents by bases. You only multiply the exponent times the exponents inside that parentheses. All right, the definition of x to the negative n, a negative power means that you take the reciprocal of whatever that base is and you change the sign on that power. So x to the negative n is equal to 1 over x to the positive n. And this is true whether if you had 1 over x raised to the negative n power, that would equal x to the positive n power because x is the reciprocal of 1 over x. So whatever the base is, if you have a negative exponent, you flip that base. You take the reciprocal of it, change the sign on the power. All right, so we're going to look at some examples that will hopefully cement all this in. So here we have 1 over 3 to the negative 2. You want to take the reciprocal of 1 over 3 and raise it to the positive 2. The reciprocal of 1 over 3 is just 3. So you're flipping it. You're moving that 3 up to the top of the fraction and changing the sign on that exponent. So 1 over 3 to the negative 2 is 3 to the positive 2, which is 9. You've got 3 to the negative 3. What do you do with it? You look at your base, you take the reciprocal of it, and then raise it to the positive 3 power. So that is 1 over 3 to the 3rd, which is 1 over 3 times 3 times 3, which is 27. Here you have a negative 3 to the negative 2 power. Don't even think about messing around with these two negative signs here by somehow canceling them out. You know, there are crazy thoughts that go through your mind, but don't do that. You take the reciprocal of the base. The base is negative 3. It's in parentheses. The exponent is outside the parentheses. So that exponent is supposed to affect the whole thing, the negative and the 3. So you take the reciprocal of negative 3 and you raise it to the positive 2 power. So that is equal to 1 over, remember, when you have negative 3 in the parentheses and the square outside the parentheses, that means you're multiplying negative 3 by negative 3. So that is 1 over positive 9. Here, you have a negative sign here, you have a negative sign here, you have a negative sign there. You've just got a lot of negative signs. Don't get confused. This negative sign that's on the outside has nothing to do with anything. It's just sitting there. So don't mess with it. Leave it there. It's not affected by the exponent. It's not affected by this negative sign. You can't do anything with that thing sitting on the outside. Leave it alone for a minute because you've got to deal with exponents first. Remember, please excuse my dear Aunt Sally. This is your order of operations. The first thing you're going to deal with is parentheses and exponents. So this little negative sign sitting outside the parentheses is not your business right now. You deal with the other things first. Leave that negative sign just sitting there. All right. So inside the parentheses, you have this -3. You want to raise it to the -3 power. Well, to do that, you have to take the reciprocal of it, so 1 over -3, and change the sign on the exponent to make it positive. So now you have negative. That negative sign is still there. It's not going anywhere. And down on the bottom, you've got -3 in parentheses raised to the 3rd power, which means -3 times -3 times -3. And so that is the negative on the outside, still there. It's not going anywhere. The bottom, -3 times -3 times -3 is -27. Now you have two negative signs that you can actually cancel because there's no more parentheses left. There's no more exponents left. You've got negatives here. So these can cancel each other out and you just end up with 1 over 27 is a positive number. All right, now you want to simplify this big mess. So remember, when you multiply like bases, which is what's happening here, this is all multiplication. This only works if you're multiplying things together. When you multiply like bases, you add the exponents. So I'm just going to go ahead and group the like bases together. X squared, x to the -5, x to the +5, and x to the 0. I've got all those, and then I've got y with no exponent on it, but that just means the exponent is 1. And then you've got y to the -4. So I'm going to look at my like bases. They're all multiplied together. I can add the exponents. So 2 minus 5 plus 5 plus 0. And then for my y's, I've got 1 minus 4. So my final answer, these 5's are going to cancel, and I'll have x squared y to the -3. This says write your answer with all negative exponents. Well, the -3 is negative, but the 2 isn't. So the way I need to deal with that problem is I need to take the reciprocal of x and change the sign on the exponent. So I'm going to leave the y on top, and I'm going to move the x squared down to the bottom and call it x to the -2. That's the way I can get all my exponents to be negative. All right, here's another one with all kinds of stuff going on. The first thing you would want to do here would be probably to go ahead and apply all of the power rules you can see there. You've got things in parentheses being raised to another power. I'm going to deal with that first. So that x at the beginning is just sitting there. We're not doing anything with that yet. We're going to deal with this first situation. You have x to the -3 squared. Multiply the exponents. So you're going to get x to the -6. Then you have a y, just leave it alone, put it right there. The next thing you have is xy to the -2 raised to the -3 power. That means you need to multiply that by the 1 in the exponent there and by the -2 in the exponent there. So you're going to have x to the -3 power and then y to the -2 times -3, which is 6. So that's the whole numerator. On the bottom, you've got y squared raised to the 3rd power, multiply the exponents, and you're going to get y to the 6th. Then you have a y to the -3. That's not anything you need to mess with right now. Then you have x squared raised to the 3rd power, multiply the exponents, and you're going to have x to the 6th. Well, first of all, let's check and see how they want the problem to be left. This is write your answer with all factors in the numerator. So since I'm going to be putting everything in the numerator anyway, I can just go ahead and move everything up to the top by changing the sign on the exponents on the things in the denominator. But before I do that, just because y to the 6th is on the bottom and y to the 6th is on the top, those are exactly the same. Their exponents are the same. Their bases are the same. There's nothing different about them. There's not a negative in one and not in the other. They are exactly the same. If you multiply by y to the 6th and you divide by y to the 6th, it's just like you didn't do anything. So cancel those out and make them go away because there's no point in even messing with them. So we're going to just move everything up to the top. So we have x, x to the -6, y, x to the -3. That's what's left in the numerator. And then in the denominator, we have y to the -3, x to the 6th. I'm going to bring that y to the -3 up to the top and change the sign on the exponent so it's y to the +3. I'm going to bring the x to the 6th up and change the sign on the exponent and make it x to the -6. Now I'm going to arrange everything so that the like bases are next to each other and I can add the exponents on the like bases. So I've got all these x's, and then I've got y and y cubed. Now I can add my exponents. The exponent here is 1. So for my x's, I've got x to the 1 minus 6 minus 3 minus 6. And for my y's, I've got 1 plus 3. I can add the exponents on my like bases. And so I've got 1 minus 6 is -5, minus 3 is -8, minus 6 is -14. So the exponent on x is -14, and then y to the 4th power.